Hello and welcome. Thank you for your time today. My name is Philipp Amon. I'm Unmanned Business Division Manager at RIEGL Laser Measurement Systems in Austria and your moderator today. So a quick poll is going to pop up now. So please go ahead and take a few seconds of your time and answer the poll question. You can see that, it's more or less all equal with airborne, unmanned, and photogrammetry, and a few of you using all of these acquisition methods. So it's getting quite interested in a couple of seconds when we're getting started with the presentation. So again, welcome to this today's webinar, which is titled UAV-based high-density LiDAR city mapping. And it's my distinct pleasure to introduce our presenter of today's webinar, Mr. David Monetti, CEO of Skyability from Austria. David graduated at University of Technology in Vienna and holds a Master of Science in Mechanical Engineering and Management. And since 2016, he was working as self-employed person for Skyability. And since 2017, he's also shareholder of the company. So David is going to tell us a bit more about Skyability in just a few moments. So David, hello.
Hello, Philip. Hello.
Hello. Okay, I will switch and hand over to you, and so we're ready to get started.
Thank you very much, Philip, for your warm introduction of this upcoming webinar. At this point, I will also say thank you to RIEGL, who gives us this great platform to talk about state-of-the-art mapping technology. And let me roll out in the upcoming 30 minutes our experiences with producing LiDAR and photogrammetry data on a daily work basis. Hi, again, my name is David, and I'm representing Skyability. Skyability is a drone service company located in Austria, raised up by my two friends, Lucas and Philip, in 2015. The deepest DNA of Skyability is to deliver high-quality information gained out of sensor systems, mainly carried on a drone. Yes, I dare to say Skyability is in Europe one of the leading drone service companies, but pushes the limits every day. In this ongoing webinar, I will roll out in which services Skyability mainly operates. I will show you with which tools we are working and what products we produce on a daily basis. After that, I'm really excited to talk about high-density mapping, what we understand of high-density point clouds, and what are the main reasons why we do that. There will be also a short comparison of LiDAR and photogrammetry. And last but not least, I will show you a real impressive project we have done this year to show you what we understand of high-dense mapping. Services HighSky. For sure, you know how fast the market of drones and payload technologies is growing and how fast technologies become outdated. Because of that, our main focus of Skyability is not only to do UAS operations HighSky, it is also to collect newest information, reflect over them, and make high-quality decisions. Skyability operates nowadays 7 drone systems from 5 to 25 kilograms and do operations mainly in Austria, Germany, Switzerland, Italy, and Hungary. One main business unit is the mapping services and documentation. LiDAR and photogrammetry HighSky means for us to collect high accurate inventory data and process them to high quality information. We do that with our LiDAR system RIEGL VUX1 SYS and RIEGL's VZ400 EDA, and as well with our camera systems Phase 1 and Sony Alpha. What we really like is to melt them all together and produce seamlessly documentation for our customer. On the other hand, Skyability has its strengths in collect inventory data for inspection purpose. Inspection HighSky stands for take the right sensor system to locate damages in infrastructure facilities. We do that with different approaches, depending on what we are looking for. In this area, it is also important to extract information on a high level and use techniques like artificial intelligence. Over years, Skyability became to one essential player in research and rescue projects. We are working with public research organizations together to push the limits of drone systems and the possibilities of sensor technologies. This webinar stands for high-dense LiDAR mapping. That brings me to our definition of high-dense mapping. We understand it for using multiple LiDAR systems and collect data from the right perspective, with the only goal that is to have no gaps in our LiDAR data. That means that makes it most cases not sense to produce really high dense data than more than 600 points per square meter. We think it is important to use different LiDAR systems from the right perspective and guarantee that there will be no gap in our point cloud data. Most of our customers have realized that is the real value of our high accurate point clouds. In future, it is every time possible to extract information from that recording day. For that reason, Skyability is collecting LiDAR data by drone, by car. We have done it by boat, and when it goes indoors, we do it by TLS. Here you can see our tools. Most of you for sure know them, but let me say some words. The RIEGL One UAV is a very powerful LiDAR scanner, which has a repetition rate of 550 kHz. Because there is the multiple target capability, it is perfect to work with it under heavy vegetation surroundings. With the two onboard cameras, it is also possible to produce not only high accurate point cloud data, it brings you also the possibility to color your point by RGB. We use it mainly on our 25 kilogram drone system and fly up to 25 minutes. Really cool is that we can also use it on our car. We can proudly say that this have allowed us to make many measurements for the local road network operator in the past. In the combination with the RIEGL VZ400 EDA, we are best equipped to also go indoors or underground. For also collect the bottom of the road bridge, it is our first solution. That all in combination with cameras, we can do many challenging documentations. Here are some great results of our daily work. The range of application is really broad. We collect data for the street network operators as for the national hazard agencies. Our data are used for project planning, project management, and for project completion. We are flying in the nature and in an urban area. We do it for small areas and for big, up to 30 square kilometers. Because Austria has some nice mountains, we have flown over 2,500 meters sea level as well. In many cases, we collect terrain data, but often we are highly interested in building structure, the accuracy the system can deliver is in most cases decision-making for winning the order. Today, I would like to talk about UAV-based high-dense mapping. RIEGL WUX-1 UAV delivers with its pulse repetition of 550 kHz the perfect tool to produce point clouds with more than 130 points per square meter in the strip. With its field of view of 360 degrees, it is possible to collect data also over the drone, which we have done successfully flying under a bridge. We use it mainly on our self-built drone, which allows us to fly more than 25 minutes with full payload. In most cases, we fly between 80 and 150 meters above ground level, with a speed from 4 to 10 meters per second. When we collect high-density city data, we fly always in a crossway direction. This means we are also producing LiDAR strips in one direction and also in 90 degrees to the others. To our experience, it is the best way to collect all the exposed walls and brickworks. In this example, we can get, by flying at 90 meters above ground level, 130 points per square meter in strip. With an overlap of 50%, you can calculate to have more than 520 points per square meter. What is really a game changer for us is that RIEGL WUX-1 UAV collect data over 360 degrees. In combination with a very low flight level, we have this real great angle of incidence from the scanner to the brickworks. It is really amazing to have these great outcomes that every building has been collected in his floor plan. That means you can easily derive all the building dimension out of this UAV LiDAR data. In combination with the multiple target capability, it is also possible to catch construction height from vegetation. And with the oblique camera system, it allows us to produce not only a high accurate point cloud, it creates also a really nice looking point cloud, what looks like more similar to the photogrammetry point clouds. To line out the essential advantages of the WUX system, with its 360-degree field of view, we have done a comparison to RIEGL's FARCO 782. The airborne data was collected from 900 meters over ground. The FARCO 782 offers a field of view with 60 degrees. This data was produced with 50% overlap and 50 points per square meter. That means even when you fly less higher or slower with the airplane, when you don't have the 360 degree of incident of angle, the point density won't deliver all the data from the brickwork height under the rooftops. To my mind, it is very impressive to see how powerful the solution of flying low altitudes with 360 scanner degree is. I think this comparison in those pictures totally underlined the advantage again. When you are interested in floor plans of buildings, it is necessary to do it, showing the picture on the right side. Working with drones means that it's really easy and cost efficient to fly with camera systems. In many cases, collecting pictures to make photogrammetry is extremely powerful. especially when you are interested in producing orthophotos. It is the best choice. But we see also the challenges it brings. In most cases, we can say when you need an orthophoto, you have to do it. But if you need a high accurate point cloud, you should use a LiDAR system. Here you can clearly see what is the most advantage of using a multiple target LiDAR system. It will also produce many echoes on the ground under the vegetation. It is the only way you can deliver ground data as a digital ground model. Also, when it is about accuracy, LiDAR will win. In these plots, you can see that photogrammetry has a higher distribution than LiDAR. Photogrammetry is in many cases very dependent to the surface, especially when there is some movement during the capture like wind in the grass. It is very hard to produce accurate data. For explanation, the circle on the right is a chimney built of bricks. The photogrammetry here in blue was done also in Crossway flight to ensure that every side is best captured. On the upper right, you can see a cross section through the street under the tree. What we can see here is the asphalt wasn't really good for capture it by photogrammetry. Here is the result dependent on the light condition and the surface of the structure. The cross sections you have seen on the last slide was made out of this project. It is the Tabakfabrik, which is located in Austria in Linz. This area was flown by RGB LiDAR and photogrammetry as well, and we had the great possibility to compare those technologies deeply. The two videos on the right shows the same perspective in the same situation. What you can clearly see is that the photogrammetry was not able to produce the tree. But what is more interesting, LiDAR was able to collect the curbs under the tree. So it is possible to collect those data only with a LiDAR system. Now, I'm really looking forward to show you a very cool project we have done this year. It is very special for us because we think we have pushed the limits of collecting data by drone. It is mailed out of airborne data and drone data as it best. Here you can see how different the approaches have been in the project. We had to deliver the whole backcountry of the congregation. This was done by airborne laser scanning equipped with the FARCO SIM 182. In the green areas, we have to deliver ILS data with RGB, and we have also delivered an orthophoto by 2.5 centimeter ground sampling distance. For that reason, we fly drone photogrammetry over 3.2 square kilometers and colorize the airborne data by the orthophoto. And in the center of the community, we will collect the data with our VUX LiDAR system, but was also equipped with the oblique camera system. The city mapping in the center of the community has been done by 16 flights over 2 days. We fly in 90 meters above ground level with 6 meters per second with 50% overlap, and we were able to collect more than 630 points per square meter. On top, we collected over 12,000 RGB pictures to have the possibility to colorize our LiDAR data. To collect the backcountry, we do 23 strips over the whole area with 2 control strips. With an overlap of 50%, we achieve a point density over 52 points per square meter. To gain the RGB information over the backcountry, we have done 10 flights with the photogrammetry drone. More than 3,500 pictures were collected. All those data were melted together, and on the next slides you will see our outcomes. Here you can see the beautiful point cloud in the center of the area. This was done by the VUC system with the oblique camera systems. What is really impressive is to have all the walls in the data. You can easily produce information about rooftops, but also about the floor plans. Here another nice shot from the high-dense LiDAR mapping data. I think it is very powerful to have this data. Haven't not mentioned that this data is a real surveyor data. Means that every point in the cloud was controlled by 300 control objects, what enables us to talk about accuracy values under 5 centimeters. Since the data is available, it enables 2 times to have the basis, the data for architects to make planning of new facilities. It is impressive to see how rich this point cloud is in information. For every public facility, there are now high accurate data available to set up new projects. Project teams can be easily discuss what will be the best way and find solution for existing spaces. In the area of airborne mapping, we have colorized the data by orthophoto, was collected by drone. As well, the outcomes are really great. The difference to UAV-based LiDAR is good visible. The information of walls are missing. To conclude this impressive project, here's a nice shot of the airborne data. This is the time for me to say thank you to our customer who has trust in us that we will achieve his expectations. We know that we have done here something great, and I have to say thank you to the whole Skyability team. I also want to say thank you to RIEGL, who helps us in a daily business, integrates with us, and creates unique technologies for new markets. For sure, we see just the beginning of a new area of collecting data. At least I have to say thank you for your kind attention. I'm really looking forward to get in contact with you. And yes, may there are some questions right out there. Philipp?
Yeah, thank you, David, for providing us an insight in one of your latest projects. Very, very interesting. Actually, before we wrap this up, there are a few questions that came in. So there was one, I think it's more a general question, but I'm pretty sure you can answer that as well with regards to the UAV platform. Do you have any restrictions on flying a drone over built-up areas such as cities? I think you can answer this as well.
Yes, of course. We are from Austria, and in Austria, the restrictions are really strict. That means our drone system has to be special. It has to have many redundancies on board, and the drone is checked by the Austro control, by the local agency, and when you have these checks and you have this approvement, you are allowed to do these flights. So this is the only way that you can do this.
Thank you. Just in general, if you have any questions, just either type in this question box or in the chat box. We can get back to that. Just as an additional remark from my side, as RIEGL also operates platforms on its own, of course, we have the same limitations as Skyability. There are new drone rules that are going to apply by the beginning of next year on a European level, which categorize the different platforms in different categories. So you would have an open, a specific, and certified category. This also about to come. We would have a more European-wide regulation, so it makes life easier for all of us, especially if you also do projects in the neighboring countries. And I think it's also quite interesting for you, as you're not only operating in Austria, David.
Yeah, for sure. Nowadays, it is really hard for us because Skyability is not only acting in Austria, and every time we are going abroad, for example, to Germany, in Germany, it is that every Bundesland, I don't know the English word for that, there are not the same rules. That means even when you fly in Germany, you have always to check the local rules and to go to the local agency and get the go from the agency that you are allowed to fly there. So there is many bureaucracy right now to get the go that you can fly there.
A lot of paperwork needed.
Yes, for sure.
Another question that we have. I think you mentioned it briefly in the presentation, but what is the most significant difference you observe between UAV-based LiDAR data and photogrammetry? Is it about the point density, the multi-target capability, or anything else? What would you say?
Yeah, this is a great question. Thank you for that. To be honest, the major difference is still the price. Collecting inventory data by photogrammetry is much more cheaper than do it with LiDAR systems. But as you have indicated in the question, there are many pros for LiDAR, and in many cases, LiDAR is the only way to obtain the customer needs. So on first, I think for sure it's the multiple target capability. Collecting inventory data outdoors means that you have to handle with vegetation. Only the multiple target capability can handle this sufficient enough to produce real ground data. So, and on the other hand, I think LiDAR in combination with high accurate trajectory is not dependent on the light situation or on the surface of the surrounding. So photogrammetry often comes on its limits by the bad light conditions or by the wind or by equal looking surfaces. The overlap and the matching part makes it sometimes really tricky to get satisfying outcomes. And yeah, this all comes to the point of accuracy. So especially for big areas. So for example, we are doing many measurements in ski slopes. So in the past, we thought about to do this by photogrammetry, but I think this is not a good attempt. In many cases, it is not possible to mark all those control points are necessary to do it with photogrammetry. And yeah, LiDAR really has its strengths there and is the only technology for us what can guarantee the quality which we are looking out for that.
Great answer. Thank you for that. And there's another one. You highlighted in this presentation that the angle of incidence, I think in one of the first slides, it's quite of an importance for such a high density mapping project. Why was airborne laser scanning used and not other methods like mobile or terrestrial data acquisition?
As I have shown, we try to use every time the best perspective of the system. So, but I have to highlight out the angle of incidence is the most really important topic. So UAV-based LiDAR mapping has really its strengths into that you can move free in the air. There are no limitations. And that means in the end, you will get the most best perspective. So when you collect data by mobile or terrestrial, means that you will have many areas of how can I say, LiDAR shadows. So drones bring you in that situation that these shadows become an absolute minimum in the results.
And there wasn't another few questions coming in now. There's a question about the software and the processing tasks. So which software was actually used for processing of this entire data set that you just shown?
So we are working really with many different software solutions, but in processing the raw data, we are trusting RIEGL software. This is on the one side the reprocess solution, and on the other side the Rescan Pro solution, because this is one thing of the DNA of Skyability. We try to produce every time high accurate data. We don't want to produce data are looking nice. We want to try produce data are accurate. That means our first target is always the accuracy of the data, and this is the most important thing, and this is the thing where we trust in RIEGL software solutions. And after that, it depends in most cases on our customer needs. Sometimes we are also working together with other companies because, to be honest, we cannot have all those solutions in our house with all the costs and all the knowing what you have to bring with the software solution you have in your house.
Understood. And this is actually a more general question. It's actually my question. I've been with you and your colleagues through many questions at the very early stages of your progressing using our LiDAR technology, especially with the kinematic system on the car and as well as on the UAV since the last couple of months and years. And what would you say, what was the most fascinating moment since your career working with the LiDAR data?
Yeah, there are many things, but I have to say to talk about two. I think the one thing is that in every single project, the moment when the first time you see the collected data in the viewer is very fascinating. Yeah, you have the drones flying out there. Yeah, and flying a drone is great. It's a 25-kilogram drone. It's really fascinating, and go in the hills really high and really far and so on. It is also really fascinating. But in the end, the only thing you do outdoors is to push the button on, okay, now collecting data, and then push the button to off. And then you have to do the processing, and there comes that moment you get those data visible. And this is the most fascinating part, because it's also the point of, okay, we have to go back in the field. Is everything here? Is everything in the data we want to see? And so on. So, but it is every time really fascinating to see those outcomes of the collected data. And what is really great too is to discover things in our data. And this is many times we are sitting in front of our screens and say to our colleagues, hey, come here, we have to, I see something on my screen, I have no idea what is that. And these are the moments where we stand together and discuss, okay, what can be that? And one special story I have, we are standing together in front of the screen and talking about, okay, what can be that? And then suddenly our drone pilot comes in and he says, totally clear, I know what it is. I have done some pictures from them. We have flown out there by a water reservoir, was deflated, and you can see here the holes where the beaver lives, and they were sliding down the slippery floor while the drone was flying. And yes, you can see here those slide passes in the slippery floor. So this is always so fascinating that something like this comes out of the data.
Yeah, we have also seen some fascinating data in the LiDAR data. Yeah. Great. Okay, we're going to wrap this up. There are a few more questions, but we will get back to those questions by email. We will close this session now. I say thanks again to David to participate, and thank you for your time. Thanks for all to attend this webinar and for your time today. A few last words from your side, David.
Thank you also from my side. It was a pleasure for me to speak here, and yes, I'm really looking forward to push more and more the limits of collecting those really great data. Thank you very much.
Perfect. Thank you very much, and all have a nice day and stay safe. All the best.